Okay, continuing the previous workshop, we studied the thermal load and the structure are coupled to each other. Now I want to show you one technique for improving mesh if you want to have a local refinement. You already know a few techniques. I'm adding one more case. So we need to open the geometry. As you can see, um, this is the our piston, and we remember when we had a structural analysis around this fixed support, we had the highest stress concentration. So I want to have a little bit of better refinement here for this area. So uh, what I'm going to do, I'm going to use imprint technique. So first I need to have a plane which is perpendicular to the z-axis. Okay, now I created that plane, and now let's draw a circle which covers the area we want to have more accuracy. For example, this area I want to have a bit finer mesh. So for this I need to pull it. So let's wait and create a bit of angle. I want to add material and not merge it. So good. And here. So I created this cylinder here. As you can see here, when I turn it on and off, you can see the cylinder there. Now we go to prepare option and select imprint. This option is going to search to see where is the contact point between the cylinder and the geometry we have. As you can see, it identifies this area, the red lines, which they are the contact between those two geometries. And I want to keep those as my imprint. So I'm going to select OK. So now I don't have any use for this cylinder. So let's just delete it. And now you can see why imprint is very important and useful for local refinement, because now I can select this section, and before this, if I click this surface, it's going to select the whole area. By imprinting, now I have an area which I can click and select the specific area. Let's go and check what is the effect of this work. Let me open. This imprint geometry can be any shape, any size, so it's not just about cylinder. I draw cylinder, but you can draw rectangle, depends on the geometry and the area of local refinement you're looking for. It can be different. Okay, almost our geometry is here. Still it hasn't read the previous file, and otherwise we should have the imprint area here. Okay, now it started. Great, now we have this imprint area presented here. So let's have a little bit of fun with this mesh. I'm going to have refinement here, here, and the same thing for the other side, this one and this one. Let's apply and refinement of maybe 2, and I also would like to have a sizing, different sizing for this area, this area, this area, and this area, which I already imprinted, and of course with the inner part too. Let's apply. Let's go with 4 millimeter. Okay, now let's check what is the effect of the mesh refinement we applied to this fixed support, the vicinity of our fixed support. Okay, now you can see we have much better mesh around this area which I imprinted. And we already know we have a stress concentration, so the solution should be, okay, it seems I need to solve this. Okay, when we apply any change to the geometry, we need to solve again, because ANSYS doesn't know what type of change we applied, so it's going to consider problem. So no problem with this one. Let's solve the structural analysis. So the number of elements would be a bit higher, but we locally refine, and we expect it to have better and more accurate results. Okay, let's see, this is deformation and the max stress. Let me turn on the maximum. Okay, we had maximum stress here, which we have already refined this mesh. So I'm not telling you this is the best refinement technique for this geometry. There are other techniques which may be better, but to just show you this technique, I selected this geometry to apply here. Okay, thank you very much.